Hi, my name is Elizabeth Marmo, and today I'll be discussing the Physics 2211 Lab 1, focusing on constant velocity. As an introduction to this lab, I will be comparing a ball in constant motion found from a physical observation to a predicted glow script program. In this lab, we will be focusing heavily on Newton's second law of motion, which states force equals mass times acceleration, and the momentum principle stating momentum equals gamma times mass times velocity to justify our findings of a constant velocity in the system. The purpose of this lab is to use these principles firsthand to understand how a constant velocity can be achieved realistically in the system with a rolling ball on a flat plane. As an overview for this lab, my first step was to create a simulation of a ball rolling at a constant speed, which is seen on the screen. I then uploaded this to the tracker app to gather my coordinates and use that to calculate slope, and then use this information for the glow script code. With these, I then compared the observed and predicted models to indicate our final results, and the fundamental physics principles I focused on were the momentum principle and Newton's second law, as these would eliminate net force and acceleration if there is no change in velocity. In this lab, I designated the ball to be the system and the surroundings to be the floor and earth, and we found some initial conditions such as the origin. I also decided to use a slope formula and velocity formula heavily for our final calculations to prove a consistent velocity. And then within this experiment, some errors we recognize in the physics aspect will be that we are ignoring air resistance and friction and the possibility of an inclined and declined plane, as this would alter the entire scenario. Gathering the coordinate points based off of tracker, I use this to find the initial and final points and then determine the slope to be 0.426 meters per second. And then I did the same slope formula with a smaller time range at the very beginning and the very end, and found these two also were consistently the same slope. Therefore, we were able to prove that the velocity is consistent throughout the whole system. In the velocity final formula, we were able to prove that velocity final equals velocity initial. Therefore, the force must equal 0 and there is no acceleration. With this finding, Newton's second law becomes voided as we eliminated force. Therefore, there's no net force in the system and velocity will remain constant. With the calculated slope and consistency we found on velocity final and velocity initial, I entered this data into the glow script base and highlighted the lines that were altered on the screen. Because velocity final equals velocity initial, the ball's initial velocity in the x direction was then changed to 0.426. The delta t value was also changed by trial and error to have our graph match the distance coordinates we established on tracker. And then lastly, the ball's position coordinate was altered by changing the x to be the velocity and multiplying this function by delta t to adjust to our values. After running the program and getting the predicted data, we then compared this to the observed and found similarities in the findings, as they both proved a constant velocity in the system to be around 0.42 meters per second. Both the positions support the ball starting at the origin and also moving in the positive x direction. The only difference that we found in these findings was the line of best fit for each, as the coding had a perfect line of best fit, but the observed was faulted by inconsistent data points that might have arrived from human error. After proving that velocity is constant and doing some further thinking about this topic, the question arose of if the axes were changed, how would this affect the velocities recorded? With our initial system, we had the ball starting at the origin and traveled in the positive x direction, so we're basing it off of this slope. So if the ball had started in the negative x and traveled towards the origin, then the slope would have remained the same with the original one we found. But if the ball started at the origin and traveled towards the negative x direction, the velocity would have been the negative inverse of the original, which is found to be negative 2.347 meters per second. And that also applies if the ball had started in the positive x and traveled towards the negative x, which indicates it traveling towards the origin. The slope would have been the same as this. And then going off of that, another question that we addressed was determining what forces were acting on the system to indicate a net force to be 0, which we found by understanding the force of gravity and force normal. And then there was also some friction that was negligible because the number was small, and that the only initial force that was actually applied was to get the ball moving, but after that the constant velocity proves that there is no acceleration, therefore no force. In conclusion, both the observation and predicted experiments support a constant velocity in the system that are justified by Newton's second law of motion and the momentum principle as these void acceleration and a change in velocity respectively. From reflecting on this experiment, some errors that could have occurred to alter the data would have been the ball not moving in a straight trajectory based off human error and the initial push. And then to help this issue, I added a ruler to the floor to make it parallel to the camera, but this could have created some friction on the ball and affected the velocity. Then lastly, when manually clicking the data points in the tracker, this could have resulted in inconsistent data points. Thank you for watching my video.